Good morning to all of you.
Good morning, sir.
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 Sorry, Vanakkam. Sir Ajit Kumar. Sorry for the delay in 5 minutes, since I have to get the link and send it to all of you in mail as well as share it in WhatsApp. There occurred some delay. Okay. Without further much delay, let us start the session. And before I start, there was one query yesterday, like artificial intelligence, machine learning, data science. What is the difference between these three, right?
Yes, sir.
Yeah. So before I give my answer, can anyone answer that? Based on these 4 days of knowledge, whatever you gain, can anyone clarify the difference between artificial intelligence, data science, machine learning? Am I audible?
Yes, sir. Audible.
Audible.
So can anyone differentiate between those three, AI, ML, and data science?
Sir, AI is a superset where machine learning comes under the AI. So machine learning uses the AI.
Data science?
Data science, sir, is also a part of AI, artificial intelligence. It is a subset of AI, machine learning and data science.
Sir, in machine learning, the machine learns and improves with the experience. So whatever tasks are feeded to them, like given to the system, and based on the previous experience, it tries to learn and make correction.
Sir, excuse me, sir, this is Hema.
Yes, madam. Yes, madam.
Based on the data, the machine learns and it becomes artificially intelligent.
Sir, as the ma'am told, to need to be intelligent, we must have to learn. So machine learning is a part where machine is trained to behave like a human, and for learning is required data. So data science deals with the data part, that how to acquire the data, and out of the data, how redundant data, remove those unwanted data, and after using those data, we can give machine to learn about the data, and based on that data, machine will able to process it, and finally it become the intelligent one.
Sir, artificial intelligence produces actions, and then machine learning generally produces or predictions. They produce predictions, and actually data science produces the understanding level or insights for the data.
Yeah. So thank you for the different responses. More or less all the things are correct. So what I understand from my knowledge is basically artificial intelligence, when you see, it will try to mimic the or imitate the human intelligence. Okay. The whole objective of intelligence is imitating the human intelligence, thereby behave like a human. And to do that, to means basically, as one of the speaker told, when there is an artificial intelligence, what about the natural intelligence? And the natural intelligence is possessed only by humans in this world. No other living being can have that natural intelligence than the human. So, what we gain and how we become intelligent? How do you define intelligence? When everyone become intelligent, then why people do bad things or do crime and all? What that intelligence means?
The ability to solve a problem according to the problem solving.
Okay.
Sir, knowledge plus reasoning called intelligence.
Sir, is
Can you
it
repeat?
ability to
Decision
think,
making with ethics.
ability to apply knowledge and skills?
Yeah, one at a time, please.
So
Yes, Rajambal ma'am.
yes, it's a ability to acquire and apply the skills or knowledge or the skills.
Okay. And Radha ma'am, now.
Sir, ability to learn from experience.
Okay. So what we gain, how we gain the intelligence is, as Chitra ma'am told, the ability to learn by experience. And for that, we are not doing anything specially. We just carry out our normal day-to-day activities as usual, and still we are learning so many things by doing regular activities alone. And from the time your brain starts perceiving the things and understand the things and interpret the things onwards, your intelligence quotient is starting and your storage of the data is starting in your human brain. And when you come across different situations at different times in your regular day-to-day life, how are you going to react it? Because we cannot react it at every time in the same manner. Sometimes if we are feel tired, then we react it in a different way. And if we are in a very good mood, we react it in a different way for the same situation. Right? So it all depends on the how the mood of our human brain is and how you are, how active you are, and all these things, how you are going to react it to the situations, and all these things based on your mind state, you are doing that. And when you are coming across each and every activity, you do it in your regular day, you are acquiring the knowledge and you are learning that. And learning in the sense there, whatever you see it, you are getting stored without your knowledge in your human brain. Whatever you hear it, that is also being stored in your human brain. And whatever you see and whatever you feel like, everything, all whatever you do it with your all the five sensory organs, that is being stored in your human brain in different complex formats. And when those things will come across again and again in your life, you try to recollect it and you try to correlate it and do the things. So it's all, the human brain is a very good storage device as well as a very good retrieval device. Storage, whatever the sensory organs of you are working on, that is being stored in the human brain. And whenever you think of those things, you are able to recollect it. That is what the retrieval phase. And this retrieval is your human brain is as fast or even faster than the Google search engine. And when it comes to storage, there is no device at all that can store that much of data what a human brain can store. So the artificial intelligence, it will try to imitate the human intelligence. So whenever you have an artificial intelligence enabled machine, what it has is there is certain program which has been algorithmically defined so that it will be executed based on the input whatever is being given. So that machine, that what AI based machine is going to imitate the human intelligence. Whereas machine learning, if you take, the machine is going to learn by experience. So what is that experience? Suppose like a human also will learn the things by experience. Suppose the simple best example is, I think all of you know how to ride a bicycle.
Yes, sir.
Yes, sir.
So,
Yes, sir.
so when you start learning how to ride a bicycle, so you have, can anyone narrate it, how you have learned riding a bicycle?
No, sir, we are being told to perform certain tasks, says like paddling, and somebody has pushed us, and later on our own, we have
Okay.
tried to
Just
ride it.
listen. Okay.
From the slope, sir. From the slope, we try to pedal down. That's one way.
Oh, from the slope. So you have a very good controlling power, ma'am.
By falling and failing several times.
Yes, yes.
So
First, someone will
initially,
help to balance.
yeah.
First,
Yeah.
thing to balance,
Then once we get the hope, then we will start doing.
Yeah. So when you are in the stage of learning that how to ride that bicycle, each and every small tiny activity looks like a very big task. Like you have to balance it with your two hands and you have to pedal the cycle with both the legs such that you can control it and you have to apply the brake. All these things looks like a very complex activity at the time of learning. And when you learn it, those becomes those all those complex activities in the initial stage become very trivial activities. Do you agree?
Yes.
Yes, true.
So it's all when you say that if you think the task is learn to ride a bicycle, then your experience is how many times you fell down from that cycle and then you again start pedaling it, start riding it. So based on certain times, first day, let us assume that you have fallen around 10 to 15 times. Second day, reduce the number. Third day, further reduce the number. And also the distance you cover it while riding slowly increases. And at one point of time, you won't fall at all and you cover more distance. So this entire process is what called learn by experience. Similarly, if you play any game like chess or anything, initially you may have losses. You may lose with your opponent, but as you lose and lose, you gain experience of and you understand where you are making a mistake and how you are losing it. And if you can overcome those things, then you start winning it. So everything, every task a human will does is only by experience. And being the teacher, sir, your way of teaching on the current day is far, far, far better than your first day in your school, right?
Yes, sir.
So all this, whether you are 10 years experienced or 20 years or experienced or 30 years experienced, everyone has to start at one single day. That is the first day of your career. And the way you do that on that day is the most trivially, and the day after you years progress it, you do it with your experience. So each and every activity, even if it is a cooking at home or any activity you take it, and if you look at it in a skeleton wise, those activities which you are doing it for a long, long time, you master those activities because of the experience and because of the repetition of those activities. So the same sort of a human is how he is able to master those things. The machine also will does that by understanding by experiencing and by exposing it with the data. That concept we call it as the machine learning. So the machine there learns from the mistakes, just like how you have overcome falling from the bicycle, or sometimes how you overcome from losing the chess game and then start winning. So if you consider those things as a mistake, then machine also learns from the mistakes and then consider takes the every task into a generalization. So the machine can improve it on par with the human intelligence. Whereas a data science, if you take it, it is all about the data, wherein you are going to analyze and explore the different hidden patterns which are available in the data. And to do that, to explore the data and to do that analytics over the data, you need to have machine learning algorithms and artificial intelligence. As someone said, ML is a subset of AI, and the current trend of the day, that is the deep learning, is a subset of the machine learning. The difference there between these two is the deep learning will work on large and large tons of data, whereas machine learning, it has certain limitations on the data. Means if you have some reasonable amount of data, you have it, you can go for machine learning. And if you have a very huge amount of data, then understanding those data and patterns that are present in the data, machine learning algorithms may not do that. So you need to have a deep learning mechanisms. Just like if you, in the normal house, we can have the kitchen utensils that can serve to prepare food for around 10 to 15 people. But if you have any function where you have 50 to 100 people are available, you can't do that, right? With those utensils, you need to have more and more special devices required to prepare the food. The same way, for the large data, you need to have special systems and special devices required to understand such data. That is what called the deep learning. Okay. So with this, I just want to show one video first to understand what exactly is the AI and what you understood it so far and what is that in the video. Just try to correlate it. Can you see that?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
You are watching Cold Fusion TV.
Hi, welcome to another Cold Fusion video. There's a lot of buzz around artificial intelligence at the moment, and the term AI seems to be thrown around a lot. But what is it exactly? To clear things up, I just wanted to do a quick video around this topic. First of all, let's look at the definition, purest definition of AI from the time when it was first coined. The official idea and definition of AI was first coined by James.
Sir, sorry to disturb, but actually I am using WebEx through browser, and it is telling me the presenter is sharing, but I need to switch to desktop app to view this. I am not able to see the video.
Okay, okay, ma'am. Anyway, that video will be available.
Even for me, that's it.
Yeah, then the video will be available in the YouTube. You can also play that later. Okay.
Okay.
Maybe
Okay.
the device it may be not compatible enough.
Okay.
Of course, there was plenty of research work done on AI by others such as Alan Turing before this, but what they were working on was an undefined field before 1955. Okay, so here's what McCarthy proposed. Quote, "Every aspect of learning or any other feature of intelligence can in principle be so precisely described that a machine can be made to simulate it. An attempt will be made to find out how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves. Translation. In essence, AI is a machine with the ability to solve problems that are usually done by us humans with our natural intelligence. A computer will demonstrate a form of intelligence when it learns how to improve itself at solving these problems. To elaborate further, the 1955 proposal defines 7 areas of AI. Today there's surely more, but here are the original 7. 1. Simulating higher functions of the human brain. 2. Programming a computer to use general language. 3. Arranging hypothetical neurons in a manner enabling them to form concepts. 4. A way to determine and measure problem complexity. 5. Self-improvement. 6. Abstraction, defined as the quality of dealing with ideas rather than events. 7. Randomness and creativity. After 60 years, I think realistically we've completed the language, measure of problem complexity, and self-improvement to at least some degree. However, randomness and creativity is just starting to be explored. This year, we've seen a couple of web episode scripts, short films, and even a feature-length film co-written or completely written by AI. They don't really make sense, but here's a few snippets for your entertainment anyway.
I need to leave, and I'm not free of the world.
Yes, perhaps I should take it from here. I'm not going to do something.
It's not a dream, but I've got a time to stay there.
Well, I still think you could be back on the table.
It's a damn thing scared to say. Nothing is going to be a thing.
From not make is so longer of the face in the comprised. And a person is what the world on the country of have the construction of the mic could to person in front are, and how they deal to part of them.
Okay, so in the definition, you heard the word intelligence. What is intelligence? Well, according to Jack Copeland, who has written several books on AI, some of the most important factors of intelligence are generalization learning. That is, learning that enables the learner to be able to perform better in situations not previously encountered. Reasoning. To reason is to draw conclusions appropriate to the situation in hand. Problem solving. Given such and such data, find X. Perception. Analyzing a scanned environment and analyzing features and relationships between objects. Self-driving cars are an example. Language understanding. Understanding language by following syntax and other rules similar to a human. Okay, so now we have an understanding of AI and intelligence. To bring it together a bit and solidify the concept in your mind of what AI is, here's a few examples of AI. Machine learning, computer vision, natural language processing, robotics, pattern recognition, and knowledge management. There are also different types of artificial intelligence in terms of approach. For example, there's strong AI and weak AI. Strong AI is simulating the human brain by building systems that think and in the process give us an insight into how the brain works. We're nowhere near this stage yet. Weak AI is a system that behaves like a human but doesn't give us an insight into how the brain works. IBM's Deep Blue, a chess-playing AI, was an example. It processed millions of moves before it made any actual moves on the chessboard. It doesn't stop there though. There's actually a new kind of middle ground between strong and weak AI. This is where a system is inspired by human reasoning but doesn't have to stick to it. IBM's Watson is an example. Like humans, it reads a lot of information, recognizes patterns, and builds up evidence to say, hey, I'm X% confident that this is the right solution to the question that you have asked me from the information that I've read. If you want to know more on IBM Watson, you can click on the annotation now or the link in the description below. Google's deep learning is similar, as it mimics the structure of the human brain by using neural networks, but doesn't follow its function exactly. The system uses nodes that act as artificial neurons connecting information. Going a little bit deeper, neural networks are actually a subset of machine learning. So, what's machine learning then? Machine learning refers to algorithms that enable software to improve its performance over time as it obtains more data. This is programming by input-output examples rather than just coding. So So that this makes more sense, let's use an example. A programmer would have no idea how to program a computer to recognize a dog, but he can create a program with a form of intelligence that can learn to do so. If he gives the program enough image data in the form of dogs and let it process and learn, when you give the program an image of a new dog that it's never seen before, it would be able to tell that it's a dog with relative ease. Okay, so before we finish, just one last concept. Most artificial intelligence algorithms are expert systems. So what's an expert system? The often cited definition of an expert system is as follows. An expert system is a system that employs human knowledge in a computer to solve problems that ordinarily require human expertise. Basically, it's the practical application of a knowledge database. We've arguably only just got the first proven non-expert system this year, DeepMind's AlphaGo. AlphaGo is not an expert system, meaning that its algorithms could be used and applied to other things. Demis Hassabis, who was the co-creator of DeepMind, highlighted this in a Google blog. Quote, "We are thrilled to have mastered Go and thus achieved one of the grand challenges of AI. However, the most significant aspect of all of this, for us, is that AlphaGo isn't just an expert system built on handcrafted rules. Instead, it uses general machine learning techniques to figure out for itself how to win Go." He goes on, quote, "Because the methods we've used are general purpose, our hope is that one day they could be extended to help us address some of society's toughest and most pressing problems, from climate modeling to complex disease analysis." End quote. In other words, the algorithms that AlphaGo used to win Go could serve as a basis to be applied to very complex problems. If you want to know more about AlphaGo, hit the annotation now, or you can follow the link in the description. Alright, so to bring this all together and summarize all that we've learnt, let's recap. So what is AI? Commonly, AI, or artificial intelligence, is a machine or a computer program that learns how to do tasks that require forms of intelligence and are usually done by humans. And the other thing to take away, intelligence comes in many forms and has many different aspects. At this time, we just have many different types of AIs that are good at particular subsets of intelligence. So anyway, I hope that clears things up, as a lot of people were confused about what AI actually is. So anyway, thanks for watching, give this video a thumbs up if you liked it, and subscribe if you're new to the channel. Cheers guys, this has been Dagogo, you've been watching Cold Fusion, and I'll catch you again soon for the next video. Have a good one.
Yeah. So meanwhile, there is a good chat. Machine learning. So many messages, fine. There is a link also, Subhash Pujari has shared. Oh my God, lots of messages, fine. So, am I audible?
Yes, sir.
Yes, sir.
Yeah. There was a pin drop silence, so I thought whether I am audible or not. Fine.
The video was very impressive.
It was not made by me, it was somebody's. That's called Fusion, but I thought it was good, so I shared it. So all your appreciations goes to them. Yeah. Yeah, I do that. When I share the video itself, ma'am. So with that basic thing, let us come to the topic of the day, that is neural networks. Can you see my presentation?
Yes, sir.
Yes, I can see.
Yeah. So before I start, let us have a recap of what you learned with respect to this learning and all, where we have seen from the previous lectures that there are different types of learning available. One is supervised learning, second unsupervised learning, then semi-supervised learning, and finally reinforcement learning. So in this case of a supervised learning, you have the data being given like this, and also you have the some annotations. These annotations also we call them as labels. Someone has asked in last class, in Pavan's class, to change the ink. So I think Subha madam, I do not know whether she is here or not. Okay. So in the supervised learning, you have the input data as well as some labels, and you develop a model through these inputs. And once the model is developed, you are going to test the model with some fruit of the same type and check whether the model is able to detect that or not. Okay. And then if the model detects it, then you can say that it is a good model. And you can't just make the conclusion that a model is good or model is accurate with only one test sample. You have to test it multiple times with the multiple shapes of the different fruits and then come to the conclusion. Sometimes the model may not detect the correct apple or may detect some other fruit as an apple also. So just we'll make a count of how many times you test it and how many times you got a good hit, and then accordingly you measure the accuracy. So the whole process of supervised learning goes by measuring the accuracy of the model. Whereas in unsupervised learning, this is what happens. So in every home, you will be doing this activity at least twice or thrice in a week. Go to the market and buy vegetables, dump it all into one big basket, and then come back and segregate them. And of course, in between these two, due to the pandemic period, we are now making a good wash of all the vegetables here and then grouping it. So here, when you are being given like this, you are making a groups of all these according to the category it belongs to. So the unsupervised learning, whatever, leads to clustering of the data. Means clustering means making the groups. So if you see this group, in this cucumber group, all the cucumbers are similar in nature, but dissimilar to the other elements in the other groups. Means any cucumber is different compared to the carrot or compared to the tomato or compared to the onion. So each one is a group or a cluster, we call it in the machine learning terminology. And also here also you have, we make it as a two groups of this, what is this vegetable? Capsicum, based on the color. So this is what, and here for the model, we are not telling what type of fruit it is or what type of vegetable it is. So what it does is it is going to do this grouping based on how similar they are with respect to the shape, with respect to the color, and with respect to some other attribute, whatever you look at it. So this sort of a study, we call it as unsupervised learning. Then semi-supervised, you have certain portion, you have the data, and certain portion you don't have the labels. So whatever the data you have the labels, you apply a supervised learning. You have no labels, you apply unsupervised learning. Supervised learning you are applying means most of the times you are doing some classification. And unsupervised learning you are doing means you are trying to do the clustering. And then together you integrate into a model. This is what called semi-supervised learning. Whereas the last one is the reinforcement learning, where you have certain rewards being given to the data present. Simple example, in the if your kid is very new to go to the school, the kid will cry, right? Because nowadays no kid is crying to go to the school, rather they cry to go come back to home, right?
True, sir. Very true, sir.
So, yeah, yeah. Whether they go to home or whether they go to school, we generally, even I was really crying a lot in my childhood. My mother used to say that she was always afraid whether I can get some education or not. Like that, I used to cry. And then they used to, if my father is present, then he scolds me, hits me, and then make me go to school. If my mother is there at the time of going to school, then she will bribe me saying that I'll give you a chocolate if you go to the school and come back, or I'll make some dish which is liked by you, something like that. She bribes me, so that the ultimate purpose is to go to the school. So that sort of a bribing and all, we call it as a giving some reward to the agent here refers to certain data. That rewarding and all we'll see little later means the reward, we are not going to give any sort of chocolates or making any sort of dishes, but what we do is we try to consider certain data samples that wins the process in the, and certain data samples which fail to win, we just ignore. That's what the reward we say in the reinforcement learning. And this reinforcement learning is highly useful in control theory. Like yesterday, Suryakant sir was telling self-driven cars or any sort of a control mechanical, a robot control, all these places, reinforcement learning will be highly used. So the supervised learning, informally, if you want to introduce it, it is basically give the right answer for each example in the data set. So you can have either a regression problem or a classification problem. These are the two types of problems that can come across in supervised learning. Whereas a regression, the difference between the two is in the regression problem, you are going to predict a real valued output, and in the classification problem, you are going to predict a discrete valued output. Let us see what is that real valued output and what is the discrete valued output. Suppose, let us say I want to make an estimate of a house. I want to buy a house, and in order to buy a house, I want to make the estimate of the price. So whenever you want to buy some house, how you have certain initial budget in mind, and then what sort of features you look at in a house to estimate the price. May I get some response?
Area, sir.
Okay, good. The first and the foremost area.
Infrastructure facilities.
Infrastructure facilities.
Like water connection, electricity
The
supply.
access to various places.
Yeah, let us say location.
Yeah, mode of transport available nearby and everything.
Yeah.
Amenities.
So labor cost.
Budget also.
It's already built a house. You're just going to buy. Okay. So certain aspects we look at. First is the area. Let us say it is around the 3,000 square feet area, and having the infrastructure within the house worth of around 5 lakhs rupees, and the location, let us say it's a prime location, and all amenities are available. Let us say, if you see the values of these different attributes, they are all different types of inputs they possess. And any specification of a house which has a 3,000 square feet area and having the internal infrastructure of around 5 lakh rupees, or let us say 15 lakhs rupees, and the location is in the prime location, and all the amenities are there. So if you have these sort of specifications, how much does the house will cost? So roughly, let us say
50 lakh.
50 lakhs.
50 lakhs, 50 lakhs.
Yes.
Yes.
70 lakhs.
Okay, all the like people will think alike. So thank you very much. Okay. So if I have a little bit to change a difference of the specification, let us say I have a 1,000 square feet house with a 2 lakh infrastructure, and the location is also prime, but amenities are not there. Let us say it goes for around 15 lakh. Like this, different specifications, you have different costs. So when you want to buy a house, you just look at as many houses as possible and then come to a conclusion, right? So given some specification and this, let us say this is your ultimate objective, that is the price. So given some unknown specification, so let us say with the specification that has not come across in your survey, how are you going to estimate? So this sort of a problem, we call it as a regression problem, wherein I said the regression means the prediction of a real valued output. These are the real values, whether it is 50 lakhs rupees or 15 lakh rupees or whatever the amount. This is what's called real value. Real in the sense some floating values. Okay. And the problem, we call it as a regression. Means it is an antonym of a progression. Progression means stepping forward. Regression means moving backward. So any maths teacher can explain why this is called a regression.
It's comparing, like we are going to compare and tell which is the best or which is the one we have to choose. No? That's it.
Okay. So in general, when you deal with develops a model, what we do is the model, once you develop, generates the data. Whereas in this case, in machine learning, the data generates the model. Okay. And this is what we have, these data specifications like this. And through this data, whatever you have seen, we just make a model. and then we try to develop the model and then test the model with some unknown specification. This is what called regression. So if you say the price, how do we make it is, so the price equal to the area multiplied by the infrastructure, sorry, area plus infrastructure plus the prime location plus amenities. And these things will be given certain weightage depending on their values. Let us say I give some weight. So this is how we make, and what we call this price is dependent on these parameters. What are all the parameters you are going to look at it? And if any parameter changes, then the price is also going to change, whether it may increase it or decrease it. And the model, once you develop it, the model development is what is identifying these values for these weights. And then once you develop a model, then with these weights, with the given specification, you are going to make an estimate. And this is what called regression. A simple regression is. Whereas it comes to the classification, it is called a discrete valued output. Means you can say whether it is true or false, or yes or no, something like that. Apple, not an apple. Banana, not a banana. Something like that, we call it, that is what called discrete value. It's not continuous in nature. Suppose I just want to make a model to identify the gender based on the height and weight. So roughly we have around 225 participants, and if I make a plot of every person's height and weight in a two-dimensional x and y axis, let us say, and every point here represents a person where corresponding height and corresponding weight, I put some dot, and then I try to make some discrimination between the two to identify the gender. Like say the height is greater than some theta 1 and if the weight is greater than some theta 2, then I can say that the person is a male, otherwise female, something like that. This is what called classification. You are going to identify to which gender it belongs to based on the height and weight of a person. Sometimes may not be correct, sometimes we may get a misclassification, it doesn't matter at all. That what we saw earlier is the machine learning. It tries to learn by mistakes, it tries to learn by experience. So it will further develop the model in a better way so that it will not make such mistakes again and again. So if I want to give you a task of develop a model that can identify or that can do the classification between the two different types of fruits I gave, one is apple and one is banana. So what sort of a model you develop it to identify the given fruit? How do you do that?
Classification based on color?
It's very good.
Shape and size.
Based on size,
Size.
height, price,
Color,
Weight.
shape, and weight.
Taste of the fruit. Taste of the fruit.
taste is
Taste, how do you
taste or
measure
looking
it?
you cannot make.
Means you have to something, you have to make some value.
Level of sugar content in it.
Oh, more technical. So,
So nutrients doesn't.
very good.
Sir, you want only the recognition of the fruit or it's even the content part of it?
Content part means?
That is the sugar level, etc. It is the content part of it. Recognition will be only based on its external features.
Yes.
Okay.
So whenever I give this example, only I get these three, and I am happy to get two more inputs, a new set of inputs also. Okay. So these things, let us assume that for a layman, he may not be knowing how much sucrose content is present in an apple or in banana, and what sort of nutrients present in apple and banana. But any layman can able to take these values, right, based on the given effort. Means if you close the eyes of a person and put a particular fruit in his hands, by just looking at the shape and by just looking at the texture feel of that fruit with the fingers, a person can able to identify the fruit or not.
Yes.
Sir, smell also.
Smell also, yeah. What are all the sensory organs? He will use it. He just use that other than eyes and could able to guess it 99% correctly. A similar task, if you want to make it done through a machine, then the machine, what it does, it cannot touch because it has no hands. Only thing is what we are giving the data in the form of the way what a machine understands. Means the color. If you, means machine is not going to look at the color. What it looks at is whatever the value we are supplying it to that particular fruit only, it is going to measure, right? And means the machine is watching the fruit through your eyes, and machine is able to make a classification through your brain. That's what happens in really. So when you give the color, let us say I give the color red. So if I get the fruit 1, I have the red color shape. Let us assume that it is circular shape and weight. How much apple weigh? Say 100 grams.
100 gram, around 100 gram.
Yeah. So when I give this as this is what called my feature vector. Features means the attributes which are going to describe my data. Sunil sir, please try to unmute. Thank you. Okay. Features means how I am able to represent that particular fruit through these values. If I ask you to tell the unique features of Amitabh Bachchan, what do you say?
Sound.
Tall.
Special sound.
Thin.
Tall.
So if you say, if you say tall alone, whether all the tall persons are Amitabh Bachchans?
No, sir. No, sir. Good acting. Action.
Dialogue delivery.
He's a very good actor.
His voice.
Okay.
His voice.
Okay. The voice, okay, I accept. So given his voice modulation, we can immediately identify. But when it comes to tall or when it comes to good acting and all, there are many good actors. Every good actor cannot be an Amitabh Bachchan, or Amitabh Bachchan is not always a good actor. Something like that in argument goes. But his voice modulation will be, and suppose if someone does some mimicry of his voice, then how do you identify whether the person is the voice is actual Amitabh Bachchan or some mimicry artist? So there are some exceptional cases where the model can be attacked to make it a failure. But we are not bothered about such an exceptional case. But in general, the voice modulation, if it is anyone can able to recognize the Amitabh Bachchan's voice, right? And if you give that voice, or if you get, say, KBC, Kaun Banega Crorepati, or some sort of feature, then immediately all those features leads to Amitabh Bachchan, right? So the feature, whatever you are going to attribute or measure it for your data, that should tell about this. Means without knowing, without looking at this fruit, if I see this feature, then I should get a feel like this feature vector belongs to the fruit apple. And if I give the other feature, say yellow color, and which is a rectangular, let us say it is a cone shape or rectangular shape, and let us say the weight of an apple, banana is around 50 grams, something like that. If I make it, then I should be able to visualize this feature numerical values or discrete values as banana. So the feature should be like that. It should be it should lead to the data whatever you are working on. Like that, the feature should be selected. So now here the case is between apples and bananas, and in general the apples are red in color, and in general the bananas are yellow in color. You can make a classifier or you can generate a model to classify these fruits based on the color, shape, and weight easily. Now look at this example. If you look at the color alone, then that model will not work for this type of fruit, right?
Yes.
So you have to have, you cannot rely on only one particular attribute. You need to have a set of attributes that together make that particular data. Okay. So with this basic knowledge, let us come to the actual part, that is the artificial neural networks. And before that, since we started like the human is the only one creature in this world who can think how the human brain is working. So inside the human brain, you have millions and millions of neurons like this. Look like noodles type of so many neurons that are interconnected to each other that makes this brain. And these neurons will try to communicate with the other neurons and then ignite the brain to do certain actions. If someone comes into your house, then the brain is going to identify that person, and if he is a known person, then it will immediately say that this is so and so X. Then it will give an instruction to welcome the X. Then you then start tell, please come, sir, like that. You invite into your house, and every action, the brain sends the signals to you to do that. Even if I am just raising my hand, inherently the brain is instructing me to raise my hand, to move my hand like this. And even if I am talking, I am not, I know the content, but the word delivery, whatever I am doing it right now, is instantaneously coming from the signaling, from the brain signal. And if I if I give a lecture on tomorrow on this same neural network, maybe this particular part, that whatever I am talking right now may come again and again, but the previous whatever I have talked, there may be certain correlation, there may not be certain correlation at all. Right? Means the same subject, if you are teaching it regularly, repeatedly, every time you cannot use the same sort of words. Why? Because the brain thinks and gives signals of what sort of words to be selected and how you can use it. Accordingly, your mouth is playing that and the voice is coming out from you. So, artificial intelligence is the mimic of human intelligence, and whereas the artificial neural networks is imitation of the human brain. The brain alone, how it is going to work, we are going to simulate that through the neural networks. And the name neural, because inside the brain you have so many neurons available, and because of that the network is called as a neural network. So a typical artificial neural network looks like this. It takes some input data and then train themselves to recognize certain patterns which are found in the data and then predict the output for a new set of similar data. So basically, the neural network will try to mimic the behavior of a human brain to solve even complex data-driven problems. In machine learning, if you take the neurons, whatever we have seen here, so these are the dendrites, which are basically referred to as the inputs, and the nucleus here process this input and then sends the output to some other axons, some other neurons through these axons. Means through these through this portion, the data, whatever is processed, will be sent. So in the biological neural network, the dendrites that are going to be the input sources for the neuron or the human brain for every neuron to process it. So the central part of the neuron, we call it as a nucleus. So this nucleus will identify these inputs and process it and then pass the output through the axon to the other neurons. So the axons, whatever are connecting between two neurons or two or more neurons, they vary based on the thickness. Some may be very thin like this, some may be thicker like that. The neurons will be. Means the connecting links between one neuron to the another neuron. So in order to simulate that, this nucleus, whatever we are seeing it, we call it as a particular neuron. So this is a neuron. So every circle here represents a neuron. And that is being connected to the another neuron through the axon. And the axon, we said that those axons will differ based on the thickness. So we give certain weights to represent those thickness, which are these are the weights that are connect between one neuron to the another neuron. Okay. So with this sort of a thing, what we are going to get is we get certain output, and we'll see whether when this input is when you are supplying the input to a particular neural network, it tries to do some processing and gives you some output, and that output based on if you have the labels, as I said earlier, that is if it is a supervised learning, that is a data with labels are there, then you can design a neural network for classification. If you have the only data present, then you are doing the clustering, and to do that also you can have the artificial neural networks. So you have the artificial neural networks that can do the classification and also that can do the clustering. So an artificial neural network is an interconnected input and output units in which each and every connection has certain weight associated with it. At this point, if you have any query, please ask. Do you have any query?
No, sir.
Okay. Shall I proceed further?
Yes, sir.
Yes, sir.
Yes, sir. Yes.
Yes, yes, sir, yes.
Okay. So let us say x1, x2, and so on, xn, n inputs I have. Let us say I want to develop a classifier that is going to classify the fruit between apple and banana. And for that, I have different, so my classification, my problem is to classify between apple and banana. So as you said, color, weight, shape. Can you excuse me for a while? Just getting call. Yeah, I'm extremely sorry because this is the admission time, and since I'm the HOD, all the point of contact is me, and calls are continuously coming. Yeah. So coming back to our example, to develop a classifier between apple and banana, we get color, weight, shape. Let us say I have 3 neurons. And what we do is we'll try to give some neurons like this. Okay. And before telling this, let me give a basic, okay. Fine. So I get input like this, connect it. And then let us say I get an output of Y. Okay. So this color, whatever we have, the color can be either red or yellow, right? Let us give some sort of a values to this manually. Let us say red equal to 1 and yellow equal to 2. And similarly, you have weight that has already a numerical value like 100, 200, something like that. And shape, once again, circular, let us say it is 1, rectangular, 2, something like that. So when you give, means the inputs, whatever you are, the attributes, whatever you are choosing, depending on those values of those attributes, you are going to give certain numerical values so that in order to process the neural network or in order to develop a neural network classifier. So what we do is by assigning some random values like this, we just try to connect these things into a particular neuron. This is another neuron. So these weights, these attributes, they are come to this neuron with certain weights. And what it does here is, so this particular neuron, I am just writing it in a bigger way. So it gets different inputs, one color, one weight, and one shape. What it does is, let us divide it into two parts, and in one part it does the summation and then converts that output into some discrete value. Because this apple and banana is a classification problem where you assign apple as a class 0 and banana as a class 1. We want certain binary value like either 0 or 1. So when we get the input like this along with the weights, and what it does here is the summation. So let us call it as a Z. That is the sum of the products we do, x1 w1 plus x2 w2 plus x3 w3. And then this summed value, you supply it to a function to get the y. So this function, we call it as in neural networks, activation function. Let us say simple activation function can be, since our output should be either 1 or 0, let us say it is 1 if z is greater than or equal to 0, otherwise 0. Or you can have some function like this, 1 if z is greater than or equal to some threshold theta, otherwise 0. Something like that you can define. There are certain functions available which can be considered as an activation functions, or you can have a function like this also. Means some function where it has a one parameter and that parameter you are going to substitute with this summed value and then get the value. So all these functions will give either 1 or 0 depending on your function definition. Accordingly, then we can say that the fruit is apple or banana. Means when we say that the machine is going to identify or classify, means machine cannot see, machine cannot taste, machine cannot feel that and all, and machine has no brain at all. What we do is we supply the inputs, and these weights alone, they are being randomly generated. Okay, and then based on that randomly generated weights and based on the inputs being given, we develop a neural network model. Okay, so till this part, is that clear? Or should I repeat?
Yes, sir.
Okay, thank you. So if you see for a particular value, let us say for an apple, so we thought red for 1, and so we have a 1, 100, and 1, that is the shape. Let us say this is the input vector x for a particular apple. So like this, you can have around 50 apples and 50 bananas you have. So what we do is, in order to develop a model, we just take around 40 apples and 40 banana, means you take 80 feature vectors. And what we do is, first time, let me put this as a one input like this. So you are giving this input vector, feature vector, and you are getting some output. And this output, so when you give for an apple, the output is one apple, it is a 0. But you may not get a 0. You may get a 1 or you may get a 0. So if you get a 0, then the weights are able to classify this particular feature vector correctly. If not, the problem is not with the input, the problem is not with the output. Where the problem lies, why we are getting a mismatch is because of the weights. Because these are the parameters that are going to control your neural network. And since we start the neural network with randomly chosen weights, because if we give our own, then we may be biased to a particular class. So we take random values, and those random values may give or may not give the correct result. So if the correct result is not been given, then we'll try to rectify, find the error. Means I want to expect a 0, but I am getting 1. So the difference between the desired output and the expected output can be called as an error. And using that error, we try to change the weights. So this part, we call it as a learning mechanism. So the learning, the machine is learning, means it is trying to, that is equivalent to, it is going to adjust the weights such that it will give the correct value. So for a particular sample, I start with the random weights and I get a value. Accordingly, let us assume that there is an error, and I'll try to adjust that error by adjusting the weights. So that adjustment, you have a different laws. Let us not worry about that. But through some equation, we try to adjust the weights so that W1, let us say the new weight equal to W1 gold. Okay. Simply, I am just writing plus or minus error. Means if there is a negative, then I am subtracting it. If the error is a positive, then I am adding it. Something like that. I just make some rule. For example, only I am taking. Based on the different learning rule, you have different networks. So the weight is getting modified. So like that, I have 3 weights. I get 3 new weights. I get it. Based on these weights, I am getting it. By adjusting the original weight along with the error, I get the weight. And now I take the second, I get these new weights. What I do is, I take the second sample. And for that second sample, these 3 new weights may be working properly or may not match at all. So what we do is, whatever the weights you have calculated here, where that my second sample will be taken, and then I calculate the output. And again, I will check that output is correct or not. If it is correct, then with the same weights, I take the third sample. So I have totally 80 fruits I have taken, where 40 from one class and 40 from another class. So what we do is, we are going to give each and every sample feature vector as an input, and then according to the output, we are going to adjust the weights. So when you do that for 80 samples, whatever you have considered, whatever the weights you are getting here after the 80th input may not match it for the first input, right? So the updates, whatever you get it here, you repeat the process by giving the first input again. then naturally you get a conclusion, when do it stop? Or should I get the weights generalized such that for all the 40 apples, it should give the correct output 0, and for all the 40 banana, it should give the correct output 1. Means till that time, you have to adjust the weights, and this process, we call it as learning. Okay, and the process of repeating this after you have totally 80 samples considered for training, and after you finish the first time the 80 samples, you are going back to the first sample and start the process. So one particular cycle you complete it, we call it as one epoch. Like this, you have to do multiple number of epochs in order to get the weights adjusted to these patterns. The whole neural network is adjustment of the weights alone. At some point, the weights get tuned to these inputs, and then finally they will behave properly. At that point, you have to stop that. And whatever the weights you get it at that particular instance of time, they are being stored. And then you have here 20 apples and 20 bananas left. You take these and use these weights and make one forward pass. Means I take the first apple and do this calculation and calculate the y. And then, so for the first test sample, I get the correct result. For the second, I get the correct result. For the third, I get a wrong result. For the fourth, I get a correct. For the fifth, I get a wrong. Like this, I will use for all the 20. And then count how many correct results I get it. Let us say around 15 times I get the correct match out of the 20. So then I calculate my accuracy as 75%. Because 5 times my model has failed to identify. So this is what happens, the whole neural network learning. What the machine learns is, it is only the weight adjustment inherently. Okay. So what we have seen is a very simple model where you give the inputs and you have only one neuron and it is going to give the output. This one we call it as the simplest model, or the first model, called as Mc-Pullough-Pitts neuron model. Then people started making more neurons. Rather than only one neuron, they have something like this. Layers of neurons, they try to put it. So this we call the input layer, and this we call the hidden layer, and this we call the output layer. Means the inputs means they are just, we are supplying the inputs to the network. And if you look at these connections in this basic neural network, we call this there are no connections in between these inputs. Only the connections are being created from this input to the other layered neurons. From this, you have all the 3 connections. From this, since there are 3 neurons present here, it is being connected. Every input is being even connected to this. And why this is hidden means the inputs, we are controlling it, or we are supplying the input, and the output layer, we are getting the output, whereas this hidden layer, where we have no control over those neurons. These neurons get input from the previous neurons, and the output of these neurons have been taken to supply to the next layer neurons. So this is why they are hidden from the user. The user or the developer cannot have a direct control on these hidden layer neurons. So this is what called as a feed-forward neural network or multi-layer perceptron we call it. Okay, this sort of a network. So when you are introducing it to the students, these sort of advanced concepts, you should be very careful and you should do it all with certain activity. That activity I'm going to do it right now with you people. A similar sort of activity, you can plan it for your students in your classes. This is what the actual perceptron, he is the person called Frank Rosenblatt. This is how the connections are there in realistic time, connecting different neurons. Means that so for that many connections in the olden days they put it like this. So a simple perceptron. So the whole training phase is what we do is with the model, we try to check whether there is an error available or not. If the error is acceptable, then the model is ready. If the error is very high, then you have to adjust the weights such that you keep this process iteratively for multiple number of epochs till you get an acceptable error. Means you never get a zero error at all, but your error can be reduced to 0.001 like that, a negligible error. Okay. So at this point, I will whether do you have any queries or whether you understood the concept of the neural network or any other queries you have, please ask. Am I audible?
Yes, sir, audible.
So, no queries?
Yes, sir.
Okay. So we'll take a break of, yes, Satyash sir.
Yeah, yes, sir. It was very clear because you used a very everyday example and it was very easy to understand. That's why. Thank you, sir.
Okay. So let us have a break of around only 5 to 10 minutes, 5 minutes or 10 minutes you want.
10 minutes, sir.
10 minutes, sir.
Okay.
10 minutes.
Because I cannot take, yeah, because I cannot take the class session, the second session up to 1:15 because on the inaugural, our Vice Chancellor could not join the inaugural due to his hectic activities, and he wants to address to all you teachers, and he was asking me to give some time and all. So finally, when I said, okay, so on the last day you come, and he gave the time at 12:45. Okay, so I have to stop the session by 12:30, and so that he can join by 12:40 like that, and then he wants to talk to all of you. Okay, so the session will not go up to 1:15. My means the actual planned session, so I have to wind up by 12:30.
Sir, you
So,
can continue now.
Not a problem, sir. 5 minutes is enough.
You can continue even now.
Okay,
Also.
sir.
Continue.
yeah, just 5 minutes. I'll take a break and send certain do some admission work, and then I'll come back. Okay, so that meanwhile you can have also a break of to have a good cup of tea.
Yes.
Okay,
Yes,
sir.
sir, sure.
So 11:35, and we'll resume by 11:40.
Yes, sir.
Yes, sir.
Yeah, thank you.
Okay, sir.
So shall we start?
Yes, sir.
Yeah, thank you. So with that, what we have seen, yeah, before doing this activity, let me take one more example, simple example. So all of you might be knowing the logical AND function, which takes two inputs and gives an output. So when both the inputs are 0, the output is 0. So this is what a typical logical AND function means. When you have two inputs, so the AND function takes two inputs and then gives you an output. So depending if both the inputs are true, then it will give true. So if this output is, I can take it as a two-class problem where all this, let us say class 1 and this is class 2. So when I make a plot between, based on these samples, let us say this is x1 and this is x2, and I have here 0, 1, and 1. When I have a 0, 0, so that is a 0, and I have a 0, 1, and 1, 0, all are this, and 1, 1, I have this, right? So this, using this, I can try to make a line. This we call it as Lakshmana Rekha, that separates the two patterns. Say this is class 1 and this is class 2. Okay, so this we call it as a decision boundary. So we can simulate a neural network, a simple neural network, to do this functioning of a logical AND. So wherever you have the patterns that are separated by a straight line like this, then we call them as such a problem or such a patterns, we call them as a linearly separable. Linearly means by drawing a straight line, you can separate these patterns. So I can say that if any dot that falls within this line here, then it belongs to the class 1, or if it falls away from the line, it is class 2. So what a neural network will do is it will try to give a discrimination boundary or a decision boundary. So how it will give is, let us see. So since I have two inputs, x1, so I take that as a one neuron and x2 as another neuron. And I have a neuron that does the summation. So the weights, they are linked with this neuron through these connections. And then this output will give it to a function f that gives us the output. So this we call Z, the sum of the products. And we give it the function, the Z, and we get the output Y. And here, in order to simulate this, we put these samples x1 and x2 one time. The first input is a 0, 0, the next input 0, 1, and then the third input 1, 0, and the fourth input 1, 1. Right? So each and every time we give these weights and check the weights, the same set of weights do classify these inputs properly or not. Means the whole process of learning a neural network is identifying the weights such that those weights should be able to discriminate all your input samples. So in doing that, what we get is sometimes we may not get the good weight convergence, means we never get some weight certain times. But what we have to do is we have to add some bias. Means suppose today afternoon you are having a test, right? So in the test, if I give the questions based on the PPT, whatever has been shared by the resource persons, from those PPT slides alone, if I give the questions, then you and I evaluate it and give the mark, then do you think that is it a right? Suppose how you conduct the test, tell me. Since all of you are teachers and you teach the students and you conduct some midterm test, unit test, that test, this test, like that, right? So do you give the questions or do you prepare the question paper only based on what is being covered by you, or do you give some questions which is not covered also?
Yes, something on HOTS also is
Usually
given.
it's based on the portions.
Okay.
Some application
Syllabus
based
will be
questions
covered, sir, but
introduce
it can
based.
be extra.
Sir, we check the understanding of the concepts.
Exactly. So if I prepare some 10 questions, at least 6 questions will be which is exactly been covered, and some 4 questions or some 2 questions you really test the student's intelligence and his level of understanding by putting some twist in the question. And that twist, if the student catches that pulse, then those students alone can answer those questions. Accordingly, you can discriminate the student's level of understanding, right? Means
Yes,
they
sir.
are also within the scope of the syllabus being covered, but needs a little bit higher level of thinking than a normal student does. And in the beginning, you do not know how the student's level of understanding is. If all the students' level of understanding is at the same level, then everyone should get a distinction. But unfortunately, no, all the students may not get a distinction. The marks will vary. Even though the same teacher teaches the same content, how the student has been received, that's what matters. And accordingly, the level of understanding helps them to score higher level of marks. So if I just make a graph, say I give some training, okay, and I conduct a test, and let me call error the difference of the maximum marks and the marks you scored. And if it is like this, means I give only the training, so this is what the training size. Okay, I give the questions only from the slides, so the error is very less. But if I give somewhat higher level of questions, that makes you think this is what called the validation. Okay, so if I twist the questions, then the gap between these two, let us see. We call this high variance. Means the training, whatever has been done, would able to make the learner answer those questions which are exactly being covered but the learner could not able to understand and make the level of he could not able to think and answer the questions. So this sort of a thing, we call it as a overfitting. Means in the same apple banana case, out of the 100 samples, we divided that into 80-20, where 80 samples we took it for training. And then we have run epochs and get one final weights, W1, W2, W3. And then if you use again the same 80 samples, then the model is working fine. But if I give these 20 samples, I am not, for this 80 samples, once again, if I test it, I get 100% accuracy. But if I use these 20 samples, I am getting 75% of accuracy. Means the model would able to recognize these patterns, but fail to recognize all these patterns. And the difference lies is more than it is 25% of variation is there. So we call this as overfitting. Means you have given overdosage of learning that makes the neuron could not able to generalize the patterns. Means overfood we cannot give so that the student cannot digest it. We have to give it regularly whenever there is a need. So like that we have to induce these concepts slowly into the brains so that they can make the level of understanding better. Similarly, if you are
Sir, can
having a
you
very
just
high
tell me
error,
again overfitting concept?
means
Overfitting
a simple
concept, can you just...
Yeah. If I ask you the question, what is being covered by me alone, and if you are able to write those questions alone, if I ask something new, a little bit variation, and you fail to do that, then it is called overfitting. You could able to answer only to what is being given in the notebook, and you could not able to think and give the answer. That is what called overfitting. The model here would see the training samples and able to classify them perfectly, but these unknown samples, this is what called twisted questions. These samples, when it comes, they could able to fail. Like a simple, particularly science teachers might have experienced this, or English teachers might have experienced this. So when they give the test, in general, English question paper contains less theory questions and more grammar, right? And science
Yes,
also less theory and more problems. So in the problems, all the problems we cannot solve it in time. The time doesn't permit us. So for every concept, we solve certain sample problems and ask the students to practice the rest. Similarly, the grammar, every nook and every corner of the grammar cannot be taught because of the time limit. So they teach the grammar to some extent and ask them to practice more. And the students, a normal average student, what he does is he only see the grammar that is being covered in the class and only learns the question and answers. And a science paper also, he will learn the question and answer, but fail to solve the problem. That is what called overfitting. Such students needs a special care. Means what is taught, the student can able to reproduce it. What is not taught, his brain is not smart enough to understand the question and think of it. Here the model, what is being known, it is able to identify it properly. What is unknown, it could not able to give the best research. This is what called overfitting. Understood, ma'am?
Okay, sir, it's clear.
Yeah, thank you. So in order to overcome this, we add another neuron called bias neuron. This has always the input 1. with some randomly generated weight. So the bias input always has a input value 1. So your input vector, feature vector is now 1, x1 and x2. Means it is x0, x1, x2. x0 value is always 1. So I replace it with 1. Okay. So now I need to find some weights W0, W1, W2 such that I could able to classify these patterns perfectly. Okay. So and our output is Z equal to X0 W0 plus X1 W1 plus X2 W2 here, right? And then we do that. So this is what called the discrimination boundary. So x0 is 1. So z equal to w0 plus x1 w1 plus x2 w2. In order to find the line, we try to equate this to 0. So you get w0 plus x1 equal to 0. So if you take this and take the others to the other side, now x2 equal to minus w0 by w2 minus x1 times w1 by w2. Simple mathematics. And if you remember this, this is something like y equal to mx plus c, where y is your x2 and m is minus w1 by w2 and c is minus w0 by w2, equation of a straight line. So this is what the discrimination boundary, you get it to, means you can have multiple lines like this. Something like this you can have. But an optimal line, you get it through the neural network by adjusting the weights. So whatever the weights values, you get it here. If you substitute it, that becomes your discrimination boundary to separate the two patterns. Certain times, suppose if you take the XR, which has the x1, x2 and y inputs. So do anyone know the truth table of XR?
Yes, sir.
So this is how the XR is.
Yes, yes.
So x1, x2, so you get 0, 0, and then 1, 1, and then here. So this is what called linearly inseparable. I cannot draw a straight line. If I draw a straight line like this sample is wrongly placed. If I draw a straight line like this sample is wrongly placed. This is what called linearly inseparable. So I need to have some sort of a curvature like this to, so that I can say that any point that lies within the surface belongs to class 1 and outside the surface belongs to class 2. This is what called non-linear separable or linearly inseparable. Okay. So this is how slowly you can induce the neural network concepts to the students. Now I'll come back to the activity. And to do that, I need some representatives from you people. And I have the data set also, so that is there Do you have at least 7 teachers from the same school?
I think it is New Era.
Okay. New Era is of which state?
Gujarat. Gujarat. Vadodara.
Oh, Vadodara. Yeah. Okay, let me first filter that. Oh, there are so many new errors, all representing the same. So all these people are the same school?
Yes, sir.
Lineta,
Yes, sir.
ma'am. Okay.
If it is Vadodara, yes.
Yes, sir. Yes.
Yeah, some has given Vadodara and some has not specified. Okay, I think you can identify the names right. Lineta, Jitendra Patel, Gita Iyer, Rupa Mehta. Okay. And the others,
Yes.
I request all of you to just patiently look at what is being happening. And I am going to send, how many are there? 13 are there. Okay. Okay, I'll split it here itself. 7 people I take.
Sir,
Pardon?
I might leave the meeting right now, right? Because I have a class at 12:10. So I'll be
Who is
joining
that?
Priya Nair here.
Okay, ma'am. Priya, ma'am. Fine. Okay. Yeah. Fine. I'll send to these first 7 people an image. I just sent you a mail. So the rule says you are not supposed to talk with anybody else. I request the participants to mute, please. Yeah. So no one is allowed to talk or discuss till the game ends. And the fun of the game lies in playing it honestly. So you all 7 has received a mail, a picture, right? So from that picture, don't talk to any of the other people and make at least 6 words that describes the just one word like that. You have to make 6 words. So you have the image and you have to play it very silently. Means one has to write a word on a small piece of paper and pass on that without speaking to the others. I'll tell, do not pass it right now. Just make a word like that. Make 6 words. So what we are doing here is, so I have selected some 7 people. Okay. So person 1 to person 7. So, and I'll take another 6 people from a different school. So what I do is, So each person has to make 6 words, okay, and then pass those 6 words to these 6 people. I'll tell who is this set a little later. I'll tell. Okay, and from your school, 13 are there, and out of which Priya madam says she'll be leaving. Okay, you make 5 words only. So this is how the network goes like. So have you received the mail?
Yes, sir.
So you could able to see the picture?
Yes, sir.
Okay, then make 5 words of it.
Okay.
Whatever we can see in the picture, no, sir?
Yes, whatever you can see.
Okay, then we have to pass the words on WhatsApp?
I'll tell. Just make the 5 words and keep it
Okay,
ready.
okay. Okay, sir.
So all the 7 are making 5 words?
Yes, yes, sir.
Okay, good. Then can you pass them to other than Priya? Do you have the mail IDs of other people? Okay, I'll send you. I request the participants to keep silent. So I am giving you the mail IDs of the other 5 teachers of your school. So you pass your 5 words to all those 5 people. So everyone has to send those 5 words to all those 5 people. And Anuradha ma'am, Adarsh ma'am, Leena ma'am, and Deepa ma'am, and Hitesh sir. You receive from each of these other faculty, you receive the words, right?
Sir, I'm yet to get, I'm not getting.
Yeah, they will send. Please wait. Okay. So the other 5, have you received the words? Radha ma'am,
Not yet, Mr. Gates.
Sir, sending. Just give me 2 minutes. Give us 2
Okay,
minutes.
okay.
Okay. Thank you.
So we have 7 people, 5 people here. So each person will be receiving 7 words.
Yeah, I got from one teammate. I got from one.
Okay, ma'am, keep those words. Do not disclose.
Okay.
The words may be repeated also. Okay, but whether they are repeated or not, do not disclose it. So Anuradha ma'am has received, and what about Adarsh ma'am, Leena ma'am, Deepa ma'am, and Hitesh sir?
From one participant only.
Even I have received from one participant, sir.
Hello, sir.
Yes,
I got
madam.
from one teammate.
Okay. I request all the first 7 people to send it fast.
I have received from
Sir, it is
Geeta.
taking time. We are doing it. We are hurrying up, but just taking time to type the address again and again.
Just 5 words, ma'am. 5 words.
Yes, sir. Yes, sir.
You can do CC and BCC and send it to all.
We are copying.
No. You are not supposed to know the others.
No, those 7, if they send it to us, we are the remaining 5.
No, ma'am. See, when
Those 7, all
okay.
of them are sending it to us, no, sir? They're all sending it to.
Because they will be sending you one word. Okay.
Now, what they have done is we have got from one teacher, she has sent all the 5 words.
Gone case.
Oh, then you understand the theme, I guess.
See, the theme is these 7, ma'am, the first 7 people, just listen to me.
Correct.
You have to make 5 words and send those 5 words to these 5 people, choosing one word for one person.
Yeah, so they have sent all the 5. They were supposed to send one each to the 5 participants.
Maybe I have not specified that point.
Yes,
so the whole
sir.
activity. Okay. Then, ma'am, Leena, ma'am, you just be away from the team, away from the game.
But sir, I have sent to all the participants, all the 5 words.
I have also sent, sir.
Okay.
So this was not specified. So that is what went wrong.
That was not clear.
Yeah, I'm sorry for that. Let us now just forget about that game and we resume the game in the afternoon once again. Okay. And I'll send another picture. Okay. So I will stop this temporarily because yeah, thank you. So okay, I will send these people again another image, and what you have to do is make 5 words, and every person has to send one word to the other person. Randomly, you choose. Suppose Leena ma'am should be given this word from.
Now we understood, sir.
Okay, like that, you randomly has to send 5 words, 5 words to all the 5 people, so that each person receives 5 words from these 7 people.
Different people.
Okay, we got it, sir. We have to one word to each of them.
One to each.
Yes. Now, since you have already sent, forget about that image. In the afternoon, I will give a new image so that you can do that. And for the time being, just put a full stop to that activity. We failed miserably on the first attempt. So that is again. So this experience will make us learn better and do that exercise again correctly in the second attempt.
Okay, sir.
Yes, sir. Thank you, sir.
Yes, sir. Yes, sir.
And we just wait for our VC to join, and he is very eager to address. So Divya ma'am has a great laugh. Fine. From which school? Is it from the same school? Divya ma'am? MBM, okay. Chennai, oh,
But
okay.
even though we failed, sir, we enjoyed this whatever we did.
Yeah, this you can do it for the students also, okay. And
Yes.
for some time after the valedictory and before the test, I will go through that. I will show you the integration manual book, okay, where the CBSE has given these sort of exercises for all the subjects and for all the classes from 6th to 10th. Leena ma'am, you are muted.
We have gone through the book. We have got in our school and we have gone through the book as well. The integration
Okay.
manual, AI integration
Okay.
manual.
Raj, they have given this kind of.
Sir, Leena ma'am
Okay.
is our principal.
Yeah, I know. And I have just why I marked it
Yeah.
in my list of participants so that I can target them for giving a feedback on the in the valedictory.
But nothing technical, okay, sir. You should not be asking any technical because I have an English background, but I just joined to know how the program goes and what are we supposed to do. The
Yes,
teachers
ma'am.
and the school.
The technical thing I will ask you in the test only.
Some of the things have bounced, but then I tried to
Yes, I
participate.
understand. I do understand, but in 5 day time, it is not sufficient. Only we can
Correct.
give certain essence and catch
Right.
that essence and then develop that for your activities in the class. So that
Correct.
the the entire the circus of these 5 days is to make the learning little bit more fun, with the learning with the fun, so that the students don't get demoralized in their absence to the school.
Right. Correct, sir. Thank you, sir.
So just be patiently wait for the wait so that our vice chancellor will soon join, and then after his address, based on the time, whether we can continue the activity immediately or post valedictory, and before the test we do that.